In this video, we are going to do a proof involving matrices. So the problem says if A and B are n by n invertible matrices, prove that A times B is also invertible. Okay, so we are in our section on determinants here, and we're trying to do a proof. So at some point, I'm going to try to leverage the fact that we have determinants at our disposal to do this. Okay, so first, I want to give you a couple minutes to try this. Remember that when we have a proof, we always begin with some scratch work where we think about what it is that we're given, what it is that we want to show, and then we try to work with both of those and eventually get a connection between what we're given and then what we want to show. And once we get that connection, we are ready to then write up the proof. Okay, so pause the video for 3 minutes to try this first. Pause it in 4, 3, 2, 1, pause it. Okay, so hopefully you tried it. Let's talk about it now. So we are given, I'll put a bullet point, that A and B are n by n invertible matrices. So they're n by n and they're invertible. And I am trying to prove that A times B is invertible. So I'm trying to prove that A times B is invertible. So now that we have determinants at our disposal, they give us a very powerful tool to test for whether a matrix is invertible or not. Because, if I'm trying to show AB is invertible, that's equivalent, so I'll put a double-sided arrow, to saying that its determinant should not be equal to 0. Okay, so if I could show its determinant is not 0, we'd be done. Well, if I go to the given side, I'm told that both A and B are invertible. So if I use determinants on that, that would tell me that the determinant of A and the determinant of B, well, both of those are not equal to 0. Both of those determinants are not 0. So now I'm almost there. What's the connection between both of these determinants not being 0 and then being able to say the determinant of A times B is not 0? Well, we have this determinant property that says the determinant of A times B, that's equal to the determinant of A times the determinant of B. And because on the given side, I know both of those determinants are not 0, that's going to mean that when you multiply them together, that's not going to be 0. Because two non-zero things multiplied, that's not 0. Okay, so I'm seeing the connection. So at this point, let us draw a line underneath this. We are, I think, done with the scratch work, and we're ready for the proof. So I always start the proof off by writing down the stuff that we're given. So in this problem, that is, I'm going to let A comma B be n by n invertible matrices. Okay, so in the proof, I write down all of my steps using complete sentences, really justifying what I'm doing each step along the way. So I'm going to let A and B be n by n invertible matrices. So this means, now I'm going to break down what this means in terms of determinants. So this means that the determinant of A, comma, the determinant of B, both of those determinants are non-zero. Both of those determinants are non-zero. And just like we did in the scratch work, now I'm going to consider the determinant of A times B. So let us consider the determinant of A times B. And I'm going to use my determinant property to say that this equals the determinant of A times determinant of B. And that's using a determinant. I'm just going to abbreviate determinant, a determinant property. Okay, and we know that both of these determinants are not 0, so multiplying them together is not going to be 0. So this is not equal to 0, and I'll give the reason why. Since determinant of A and determinant of B are non-zero. Sorry, I'm writing's kind of small because I'm running out of room here, so I'm trying to fit it in this page. So what is it that we've shown? We looked at the determinant of a times b. I've shown that that's not 0, but using our determinants, if the determinant of something is not 0, that means that matrix is invertible. Well, this shows that the matrix AB is indeed invertible. It is invertible, and that's the conclusion I wanted to prove. So now we are done with the proof. And there we have it. So notice again the process when we do these proofs. I always started off by doing scratch work, where I think about what it is that I'm given, what it is that I want to show. And then from there, we got to think about it. We got to think about what it is that we're given, what are some of the things that that tells us. Often I may have to work kind of backwards, and I think about what it is that I want to show, and what would it take to show that thing. And once we form a connection between what it is that we're given to what it is that we want to show, that's when everything falls into place, and I have all the steps. Once I have that, now it's just a matter of writing that up cleanly in the proof using complete sentences, fully justifying the steps that I'm doing.